crossing them with now all of them. So there it is. This 1 and 2 is crossing them with 1. Now, so for division, I guess this is a perfect example. As I said, this is page number 39, and pretty much all of the symbol that we are trying to learn, that is working on this example, which is page number 37. So before you start on your project phase 2 as well as your homework, you can always look for this page number 37 example. And the data, the PDF file that I'm showing for so many times, it's in your lecture 5. And we are discussing today lecture 6. So it's lecture number 5, page number 23. So if you feel like, okay fine, from where those is coming from, then you have to go back into lecture 5, page number 23. So then you will realize that those are coming from based on those data. So far, we are trying to learn this today. So now we'll try to learn from some aggregate function, which is these things, functional operator. Functional operator, nothing but only the numerical relation what you are trying to retrieve, which are maximum, minimum, average, sum, or count, all of them. Sum, all of them. And also count function. So, I hope you know, right? Or if you don't know, just make a note. If anything about aggregate in database, then count, sum, average, maximum, minimum. That's what I mean when it's aggregate. So, like here, there's some example. Like if you're trying to count something, so like for here, maximum salary from the employee, that retrieves maximum salary value from the employee of relationship. When I'm saying salary, can you tell anyone that how many columns it will return? These things? Only the salary.
Only one.
Sorry?
Only one.
Yeah. So if it's an aggregate function, it will return only the salary that you are mentioning with the aggregate function. When I'm saying count of SSN, average, and salary, yeah. So can you tell me how many tuple or record finally it will return? Just only one, because it's count. When it's count, then no matter what, how many records you have, if I'm counting all of them, then from department I'm returning only 3, which is numerical 3. When I'm saying from count up there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13. So when I'm saying something, it will be interesting when you will try this on Oracle, or maybe some of you already tried in your experience in SQL, then you will see the difference. Like when I'm saying count, then only the number of the things that I'm trying to count, that will return. So now, recursive closure operation. That's a very abnormal stuff. I never see this to use in practical life, but we have to learn that. In this page, I didn't find that much interesting the example, but still it's kind of nested. So the example of the is we are trying to retrieve all of the supervise of an employee E at all level. For example, we all probably know Mr. Tarek Sof, who is Dean of the Engineering. And then we probably know all of Professor Asif Mahmood, which is Dean of Computer Engineering, and then, for example, Professor Lee. So Professor Lee basically works under Professor Mahmood, and then Professor Mahmood works under Professor Tariq. So if you think like that, then there's two nested things, right? One works on under, one works on another. That's how it works. When it's recursive closure, then you have to first, you have to start from the bottom, like from Professor Lee and Professor Mahmood's relationship, and then all of the relationship is how it's under Professor Tariq. So that's how it works. You can see all of the employees E directly supervised by E, and all of the E directly supervised by each employee, and then all employees. It sounds similar. And then relational operations, operations are all of them continue. So you can see, right? So this example is trying to retrieve the recursive closure, which is page number 46. Then outer join. Outer join is like the, again, if you put into there, if we forget this intersection portion, then rest of the things are outer join. So if we try to the common stuff, if we exclude them, whatever there will be remain, those are outer join. And left join is when left join is like that is R in terms of S. So if I'm thinking from there, like what is the common portion of R and S and R itself, then that is left join. If I'm thinking in terms of S, then whole S and what is the common of R and S, that is the right join. So from if it says left joint with employee and project, then employee is the left table and project is the right table. If they have common attribute called SSN or whatever, then all the employee tables value is there and the common values that are from project and employee. So if common values is like 2 column and it has 4 column, then the left join result is 6 column. If it's right join, then these two, and for example there it's only 2 is common, then 4. So if it's left join, then result is 6, but if it's right join, then result is 4. So left join and right join will never generally return the number of same value. The number of value will be different. So, queries of relational algebra will be like this. Mostly I got a lot of questions from students like what is our phase 2? Phase 2, it's all about like this. Some queries that you are descriptive queries you submit on phase 1. So that phase 1 you have to first, maybe that was not so technical language, now it has to be a technical language. So first of all, build up a technical language to express that. Remember, I have all of your phase 1. So it should not be rapidly new thing. It can be a little bit change. Can be additional more, can be from 20 to 18, but not from 20 to 5. So maybe you are trying to say 3 queries in phase 1. Okay, fine. That 3 you have to convert into first technical language first, and then relational algebra. All the relational algebra, I'm encouraging you to do the rename section, because the small section, if you rename them, then ultimately it will be easier for you to express finally. If you don't rename, then it will be complicated for you. And most importantly, maybe generally just I'll look into it, but again, you will have a checklist later on in phase 3 when you are ultimately converting your whole design into Oracle, and you're inserting data. Then if your these things is not working, then you are fully screwed. So I think first and foremost, you have to understand the example that we studied today, and then convert them into. If you're right here, mostly like 90%, you're all set for phase 3. You know, your phase 3 will be nothing. But you're just, if you do something by not understanding for phase 2, your phase 3 will be like, again, working from phase 1. And also, relational algebra is the most important and most weighted things, like more marks is more weight, if we think like that, then relational algebra is like that in midterm. Now we're saying query tree. Query tree, it's also kind of thing for renaming that row. So every little things that we are, if we try to catch them in a very small section, and then ultimately joining whole of the things, and that's my root section. So query tree is nothing but the thing, these things. So if it's like it's each and every leaf, it's a one leaf, they mix into that is a root. If I'm saying those are the leaf and that is the root, then that's how it works. So query tree is also fine in your phase 2. If you try to build like this, it's fine. So relational calculus. Yeah. So here we're trying to say to find the first name and last name of all employees whose salary is above 50,000. We can write the following calculus like this: T dot F name, T dot L name. This or stuff means which tables, and T of that whole things, and then and T is greater than 50,000. So this rules is completely different than what we just learned today. So probably from this section, Professor will teach more in next Tuesday why it's different, because from there the domain existential and universal quantifier starts. So I'll remember him that from tuple relational calculus we stopped, but he will start from here. So far we're trying to learn this symbol first, and how we can see the relational calculus we can write using them. Finish.